In this video, we'll explore a major development in energy. Grids need dispatchable power they can turn on when demand spikes. This has been under development for a couple of years, but in Japan, they have proven they can use green ammonia as a full fuel source in a grid-scale gas turbine. This milestone was achieved through a collaboration between IHI Corporation and GE. Power plants burn fossil fuels, such as coal or natural gas. While these fuels are reliable, they contribute significantly to greenhouse gas emissions. Even if there is a huge adoption of electric vehicles, we still use fossil fuels to charge the batteries. The IHI and GE project shows that we can use a different type of fuel in turbines we already have, instead of building completely new systems. This makes the transition to cleaner energy faster, more cost-effective, and more practical. Ammonia combustion took some tweaking to run properly. Conventional wisdom said the ammonia would need to be blended with another fuel, hydrogen, methane, diesel, etc. This team proved systems could run on 100% ammonia. Ammonia does not contain carbon, so it doesn't produce carbon dioxide when burnt. There are still other emissions to consider, such as nitrogen oxides, which can form under certain combustion conditions. The IHI and GE team demonstrated they can control the combustion, so the emissions are virtually air and water. In this project, the key change was focused on the combustor, also known as the burner, which is where the fuel is ignited. Although this component is critical, it is only a small part of the overall gas turbine system. The rest of the turbine, including the compressor and generator, remains largely unchanged. Instead of redesigning the entire power plant, IHI and GE developed a new combustion system that can handle 100% ammonia fuel. This means existing gas turbines could potentially be upgraded by replacing or modifying the combustor, making the transition to ammonia more practical and cost-effective. Different countries have different challenges when it comes to electrical grids. Japan has poor wind and solar conditions. Basically, it is not very windy or sunny, so there is a low return on investment in green energy resources. Further, Japan relies on imported natural gas. Gas is liquefied somewhere like Australia and shipped across the ocean in cryogenic conditions. Green ammonia creates an interesting option. Japan is importing liquid fuel anyway. Green ammonia can be produced in places like Australia, where it is very sunny, or in Newfoundland, where it is very windy, and then shipped. This is not just conceptual. It is tied to Japan's national strategy to import and utilize 3 million tons per year by 2030 and 30 million tons per year by 2050, which IHI is positioning itself to supply. IHI Corporation is a large Japanese engineering company that handles major industrial and energy projects. They've been active in energy systems, infrastructure, and machinery for many years. This experience made them well suited to explore ammonia as a new fuel source in collaboration with GE. GE has installed over 7,000 gas turbines in more than 100 countries. These turbines are currently used in thousands of power plants. The scale of this network shows the potential impact. If even a portion of these systems can switch to ammonia, it could significantly reduce emissions globally. In addition to turbine development, IHI is making broader investments in the ammonia energy space. They are building a full ammonia value chain, from production, including both blue and green ammonia, to transportation, storage, and final use in power and industrial applications. IHI is also exploring investments in green ammonia production. aligning with Japan's long-term targets for large-scale ammonia adoption. At the same time, they are forming global partnerships across regions like the United States, Europe, and Asia to develop supply networks and infrastructure. Importantly, IHI is not only focusing on supply, but also creating demand through technologies like ammonia-fired turbines, co-firing in power plants, and marine fuel applications. While there are already MOUs and demonstration projects in place, long-term supply contracts have not yet been publicly confirmed. Liquefied natural gas is used widely in power plants, industrial heating, and even transportation, such as shipping. These sectors represent potential areas where ammonia could gradually replace liquefied natural gas. The IHI and GE project demonstrates that, at least in power generation, this transition is technically feasible. The global market for liquefied natural gas is valued at over $100 billion. Even replacing a small portion of that with ammonia represents a major opportunity, both economically and environmentally. The IHI and GE ammonia combustion project proves that ammonia can already be used in real turbine systems. Since infrastructure is already in place, the next step is expanding this technology to more power plants around the world. While it will take time, this is a clear and practical step toward cleaner energy and reduced reliance on liquefied natural gas.